So today I will be taking on the topic uh, triangle, quadrilateral, and polygon of get aptitude. So, so I'm discussing some of the major theories or principles related to triangles, quadrilateral, and polygon. So let's look at the first slide. So this slide talks about triangle. These are some facts you already know. Triangles has three sides, three vertices, three angle. Then the sum of the interior angles of a triangle is 180 degree. Okay. All the sum of the three interior angles of a triangle is 180 degree. Then the sum of the length of the two sides of a triangle is always greater than the length of the third side. If A, B, C, B, the three sides, and if you take any three sides and take the sum of any two sides, it could be A and C, it could be B and C, it could be A and C. So any two combination, if you take the sum of the any two sides is always greater than the third side. Then a triangle with the vertices PQR is denoted by triangle PQR. Okay, this is the convention, the way in which you name a triangle. If it is having PQR in order, we have to write in the same order triangle PQR. Okay. The area of triangle is equal to half of the product of the base and it half BH. Okay, it is half BH. Okay. Then the difference of the two sides of a triangle is always smaller than the third side. It is just inverse of the third point. I mean, here it's a difference of two side which is smaller than the third side. There the sum of the two side will be larger than the third side. Okay, these are some of the important points related to triangles. Okay, so let's look at the next one. The triangles are grouped into two different main categories with regards to sides based on different properties with regard to sides and with regards to angles. Okay, so with regards to sides, if a triangle is called equilateral, you all know all the three sides should be equal. When all the sides are equal, AB is equal to B is equal to CA. Here we have a triangle ABC of side AB, BC and AC. If all these sides are equal, then it is an equilateral triangle. So, and also another properties of equilateral triangle is if all the sides are equal, then all the angle will be equal. And for equilateral triangle, obviously that angle should be equal to 60 degree because we know some of the angles of a triangle is 180 degrees and if all the angles are equal then each angle should be 60 degree. So that's the properties of equilateral triangle. Then isosceles triangle means when isosceles triangle means only two sides are equal. Okay, and now two sides are will be equal. Here you can see AB and B. It could be anything. It could be AB and BC or AB and IC. Anyway, two sides are equal. Obviously, the non-base side will be equal. That's how you define it. It's not BC, it's AC. Okay, it's AC. Okay, so if these two sides are equal, then its base angle will be equal. Okay, here AB and AC equal, then base angles of these two sides will be B and C. Because this is the property of isosceles triangle. The third one is scalene triangle. That means the no sides are equal, all are unequal. So of course, the angles would be different. Okay, no angles would also be no it won't be similar. So these are the uh, main category. First category regard to sides. Then the next category is regard to the angles. The next is with regards to angle. So if a triangle is called right angle triangle, if you are calling a triangle as right angle triangle means is one of the angles should be 90 degree. Okay, this is a right angle triangle. You can see your angle B is 90 degree. Then only you can call it as a right angle triangle. So in triangle ABC, angle B is 90 degree, and the angle the side opposite to the 90 degree. So the side opposite to 90 degree is AC, which is the hypotenuse. So of course by Pythagoras theorem we all know AC square equal to AB square plus BC. Then a triangle is called obtuse angle triangle. When if is one of the angle is obtuse. Obtuse means should be angle should be greater than 90 degree. Okay. So if any one of the angle is greater than 90 degree, it's obtuse triangle. Then It's acute triangle, acute angle triangle. Okay, if you are calling a triangle to be acute angle triangle, then all three angles are acute. Okay, here we have triangle ABC, or angle A, angle B, and angle C should be acute angle, that means less than 90 degree. These are the three major classification of triangle according to the angles. So the next term related to triangle is altitude. Okay, the next term is altitude. So what's an altitude? The altitude of a triangle is a line drawn from any vertex perpendicular to the opposite sides. Okay, here we have a triangle ABC. Here, as it says, we can draw from any angle. If you're drawing that angle, which is drawn perpendicular to the opposite side. Okay, so here from the point A, they have chosen the point A vertex to draw the line perpendicular to the opposite side. The opposite side to angle A is BC, and a perpendicular line is drawn. Okay, I can also like draw one line from here B to AC perpendicular. It is also an altitude. So any line drawn from any vertex to its opposite angle in perpendicular is said to be an altitude. And altitude is also called the height of the triangle. Okay, so uh, altitude itself means the height of the given triangle. Okay, three altitudes of a triangle are concurrent. Okay, this is one altitude. Obviously, I can draw another one down here like this, like this. So three altitude are concurrent. They meet at a single point. Point of concurrence is called orthocenter of the triangle. So what do you call orthocenter of a triangle means the point of intersection of three altitude is called orthocenter of a triangle. Next property is regarding the equilateral triangle. Okay, the orthocenter, you can see this is the altitude drawn. Okay, so the orthocenter appears to be directly in the center of the triangle, creating three angles of equal area. Right, it is meeting exactly at the center. Okay, so what it create is you'll be creating three triangles. You can see right the angle, a triangle ADC, triangle BDC, and triangle ADB. We will be getting three triangles when the orthocenter is formed, or three altitudes are concur. So we will get an equal area of angle, right? So you can see it. They have named as this center point is O. So area of triangle AOB, POC, and COA is same. Okay. So acute triangle is uh, there is different cases. This orthocenter acts on different triangle. For acute triangles, that means each angle is less than 90 degree. The orthocenter lies inside the triangle. Okay, but in obtuse triangle, that means any one of the angle is more than 90 degree. Its orthocenter lies outside the triangle. And for right angle triangle, the orthocenter lies at the vertex containing the right angle. Okay, we'll be having any angle of 90 degree, right? So the exact that vertex, the orthocenter lies at the vertex containing the right angle. That's regarding the how orthocenter lies between the three different triangles. Okay, acute triangle, obtuse triangle, and right angle triangle. Then regarding the median. Okay, what is the median of a triangle? The median of a triangle is a straight line segment joining the vertex to the midpoint of the opposite. We are not having an angle down here. Just like altitude, you are drawing from any one of the vertex to its opposite side, but you are meeting the other points meeting at the exact center of that side. Okay, here from the vertex A, the line is drawn to the side BC, and it intersect at the exact center of that side. So this is what called a median. So if this angle will be 90 degree, it will be altitude. That's the only difference between altitude and median. Centroid, the medians are concurrent. Obviously, just like altitude, medians are also concurrent. The point of concurrence here is called centroid. The point of concurrence of altitude is called orthocenter. The point of concurrence of median is called centroid of a triangle. So regarding centroid is always lies inside the triangle. Okay. In previous case, we have discussed the different point at which the orthocenter lies for different triangle, but unlike equilateral, unlike altitude, median will obviously lies inside the triangle, and centroid, this point divides the median in the ratio 2:1. So these are all different median, right? We have three median down here. This is the centroid. The centroid divide this line, could be any line, right, in the ratio 2:1. Okay, and then triangle ABC, G is the centroid right here. I have a triangle ABC where G is the centroid. So this same point, AG is to GD is 2 is to 1, BG is to G is 2 is to 1. Similarly, CG is to GF is 2 is to 1. So the centroid divides the median and the ratio 2 is to 1. So median divides the area of triangle into two equal parts. So here it is dividing in two equal part, not like median. We'll be having three area. Sorry, yeah, like altitude will be having three equal area, right? But here it will be having exact two equal parts. And the distance of the centroid from the vertex in equilateral triangle is a root 3. This is the centroid. So these three points are the three vertices, right? A, B, and C. So from the centroid, this distance you can see from the centroid towards the vertex, the distance C will be a root 3 by 3, where A is the uh, I mean side length of the equilateral triangle. Okay, so this is all about the media.